Let's take a look here. What do we notice on these? Yeah, I've got the same base on my exponential piece here as I have on my log. Those are inverse operations. So, all right, gentlemen, thanks. So since our base of our exponential and our base of our log are the same, they just cancel out. So this simplifies down to be just x. And holy chunky marker, Batman. Oh my gosh. Whoa. Other extreme. Okay, there we go. Let's find middle ground. So since the base of my exponential and the base of my log are the same, they can cancel out. We can only do that when they have that same base, though. So on the next one, what could I do? Whoa, sorry. What could I do here to be able to cancel out the base of my log and my exponential? I mean, you could using our properties, but I don't know log base 4 of 16 necessarily. If my base is 4, can I rewrite 16 as a base of 4? What is 16 as a base of 4? So this is the log base 4 of 4 squared to the x. When I have a power raised to a power, what do we do with those values? We multiply them. Power raised to a power, they multiply. So this becomes log base 4 of 4 to the 2x. Now the base of my log and the base of my exponential are the same. So these two pieces are inverses of each other. They undo each other. So this simplifies down to be 2x. If you did it with our logs, the log properties, like you were saying, Evan, where I put the x down in front, and then figure out log base 4 of 16, you'll get the exact same answer. We just hadn't technically talked through the properties yet, so you're pulling that back up from memory. All right, let's look at the next one. Log base 2 of 2 to the x. What does this simplify down to be? Just x. The log base 2 and the 2 cancel each other out, so this simplifies to be just x. How about 35 to the power of log base 5 of x? This one is also just x. My 35 as the base of the exponential and my 35 as the base of the log cancel out. The next two are slightly trickier. So we have the natural log of the natural log of e. So start from the inside. What is the natural log of e? One. When in doubt, think of this as log base e of e to the first. Then it's exactly what we were doing up at the top. When our base of the log and our base of our exponential are the same, they cancel out and we're left with just our power. So this just becomes 1. So then we have the natural log of 1. Is that something we know? Mm-hmm. Anything that has an argument of 1 means it had a power of 0. Because that's e to the what equals 1. So e to the 0 equals 1. So this one we can simplify all the way down. Natural log of the natural log of e is the same thing as 0. The next one is very similar. Very similar. Again, I'm going to start with the insidemost piece. Our natural log of e to the 7th. Again, if it helps, think of it as log base e of e to the 7th. What does this chunk simplify down to be? Just 7. So then we have our natural log of 7. Is that something we know? Say, is it? That's icky. I don't know e to the what equals 7. That's not a thing we know. So that's as simplified as it goes. Natural log of 7 is just a number. It's a gross number, but it's a number. So we just keep it like that. That is simplified as much as we can get. So sometimes we just have to simplify pieces. And sometimes we're going to use our simplifying as we start looking into the solving, because that's what we're going to focus on mostly today is the solving stuff. So we are going to be given all kinds of different problems and all kinds of different shapes, but we'll use the simplifying while we're solving. So questions on the simplifying? Okie dokie. So here's our first two. My iPad's freaking out. We've got the natural log of e to the x equals 4. Solve means we're trying to figure out what x is. So start by simplifying things as much as you can. So on this first one, what do we notice? What can we simplify? Yeah, I've got the natural log of e. That's log base e of e to the something. Those two pieces are inverses of each other. I'm going to write it out the same way I did on our simplifying pieces. This is log base e of e to the x that equals 4. So my log base e and my e to the power of cancel out. Those two things are inverses. They undo each other. So this is the same thing as x equals 4. This is the end of 5.4. There's one important thing we need to think of when we are solving with logs is we have to do a quick check in the middle of it to make sure we do not get negative bases and negative arguments. Negative powers are okay, but we can't have negative arguments or negative bases. So I'm just making a note of that up here at the top.
Wait, so the homework...
No negative bases or arguments. So when we have our logs in isolation, no negative bases, no negative arguments. Negative powers are fine. Bases and arguments are not. This x equals 4. It's not negative anyway, but we're just going to spot check it. Yeah, no, we're fine. I can do e to the 4. We don't wind up with a problem there. On this right-hand one, what can we do to simplify over here? Yep, my log base 4 and my 4 to the cancel out. So on this one, I don't hardly have any steps to do. We just wind up with x equals 16. Is that a valid answer for us? Yep. So if we have a base of a log that will cancel out with the base of our exponential, we have very little work we have to do. Sometimes we're not always quite that nice, though. Boop. Sometimes it'll be more like this. So slightly more complicated. And there's a few different ways you can approach these, especially the left one. The left one we could do very much like the log base 4 of 16 we did in our simplifying steps, where I make it have the same base. Or you could go switch it back from our log form to our exponential form. Either way, both of those are fine. I'm going to do this one making our bases be the same so we can cancel it out for reasons that I will show you later. So I have a log base 2. And my exponential piece has a base of 8. How could I write a base of 8 in terms of 2's? Yeah, log base 2, and my 8 I can write as 2 cubed to the power of x equals -3. So I'm replacing my 8 with the 2 cubed. Now I have to deal with this power here. Power of a power, I multiply those together. So this is the same thing as log base 2 of 2 to the 3x equals -3. We like to put them as the same base because now what happens? My log base 2 and my base of 2 cancel out, and we're left with 3x equals -3. So what does my x equal? -1. Is that a valid thing we can have in a log? Which piece of the log is this x? It's a power up here. It's an exponent. Can I have negative exponents? Yes, that just makes things fractions. Okay, we cannot have negative bases or negative arguments. So this is fine. We can have this. Let's look at the next one. Log base x of 1/4 is 2. So now I can't make these have the same base. I can't force it to cancel out like we did on the left one. Since I can't force it to cancel out, we're going to switch forms. We're going to take it from its log form back to its exponential form. So what is my base? X. So my base of x. What is the power? 2. So x squared equals my argument of 1/4. So we switched it from its log form back to its exponential form. What can I do now? Square root both sides. I'm trying to solve. It's an x squared. Square root both sides. When I square root both sides of an equation, what do we need to have? Plus or minus. What is the square root of 1/4? 1/2. Looking back at our original equation, what piece of my logarithm is x? The base. So can we have both positive 1/2 and negative 1/2 as a base? No. What is our solution? Just the positive 1/2. We cannot have negative bases. That's why I brought it up. No negative bases. So our answer is just the positive 1/2. Okay. Questions on this one? Because sometimes we're not given logs to solve, we're given exponentials to solve, but we just have to use our logs. All right, so we have e to the power of 3x plus 2 equals 7. What on earth should we do? Don't say cry. My x is in the exponent, which means, so I would like that power to come down and be not a power anymore. We're going to put it as log form, which will do exactly what that is. So I'm going to switch this from my base power argument and put it in our log form. This is going to become log base e of 7 equals our power, our 3x plus 2. Using that that pattern we wrote down the other day, RBP equals A is equivalent to our log base B of A equals P. So that's what we're using here, our BPA log BAP. That guy. Log base E, that's just ln. So this left side is ln of 7 equals 3x plus 2. I'm trying to get x by itself. Subtract 2. ln of 7 is just a number. It's a gross number, but it's a number. So we have our ln of 7 minus 2. Can I combine that together and make that be ln of 5? No. LNs, logarithms, are in the same family as exponents. So order of operations wise, logs have to happen before subtraction. So we write it like that. Still got to get x by itself though. What do we do? Divide by 3. And this is going to be a super gross looking answer, because our natural log of 7 minus 2 over 3 is our technically correct, most accuratest answer. Not super helpful if I'm trying to figure out where that is or how long that is though. So to get a decimal approximation, we type the sucker in the calculator, which is not on the screen right now because my computer's in a mood. There we go. So to get our calculator to give us a decimal approximation, we can just type in the whole fraction. Just be careful because our calculators open a set of parentheses here. So you got to make sure you close it before we subtract that 2. Natural log of 7 minus 2 is very, very different than natural log of 5. So our decimal approximation here is negative 0.018. You do not always have to give me decimal approximations, only if we specifically ask you for them or if they ask for it in the homework. Like, you can leave it absolutely in this logarithmic form. This is the technically correct, most accurate answer. This is just way more practical to work with in any other sense of the form. So this is a correct answer. This is upon request. Okay. Questions on this first one? I know it's been a hot minute since we solved like this. Okay. Then let's look at the right-hand one. What can we do here? Exactly right. I don't want to switch it into log form when I have a constant on the left. I need it to just be the exponential. So I want to actually divide both sides by 4 first so that we just have our e to the power over here. So we have e to the power of x plus 1 equals 5/4. Now what are we going to do? Put it in log form. So we're going to have our log base e of what? What's our argument? 5/4 equals x plus 1, our power. So log base e, that's the same thing as the natural log. So this is ln of 5/4 equals x plus 1. Then what? Subtract 1. So we've got our natural log of 5/4 minus 1 equals x. And again, if I need a decimal approximation, we put it in the calculator. And luckily, these calculators can do funky logs like this. So we're going to have our natural log of the fraction 5/4. Just make sure we close it before we subtract our 1. It makes a difference if you do not close that parenthesis or not. So please, please, please make sure we're being careful. So I'm going to take 3 decimal places here. So we're going to have our negative 0.777. Which feels like a Friends reference, but it's not. Okay? So again, when in doubt, you can leave it in the log form. Only if we need to, by request, do we do the decimal approximation. So upon request, we get the decimal. Questions on either of these two? Okay. We're going to have some funkier looking solving things. What do we have here? What can we do on this left one? Say it louder. We don't want to factor right off the bat. Yeah, let's get it out of the log, because ew. So we have a base of 5, a power of 2, and this whole quadratic is our argument. So when we switch this around into our exponential form, we wind up with 5 squared equals our x squared plus 4x plus 4. What do we have here? A quadratic equation. We can solve quadratics. First thing we need to do is simplify it, though, because I've got a 5 squared on the left-hand side, and I don't want to do that. So we're going to multiply out that 5 squared. So we've got our 25 equals x squared plus 4x plus 4. So what's our next step? Subtract the 25. So we have our 0 equals x squared plus 4x minus 21. Now we want to do our factoring. So our factored form would be our x plus 7, x minus 3. So our solutions, we have x equals negative 7 and x equals positive 3. Our x's are in which piece of our logarithm? Our base, our power, or our argument? They're in the argument. So we need to make sure that we do not wind up with a negative argument. Do either of those cause us to have a negative argument? Negative 7 squared would be positive 49 minus 4 times 7, so minus 28 plus 4. Would that be negative or positive? It's going to wind up positive. Even though it's a negative x value, we'd still wind up with a positive argument, so it still works. This one also works. So we have two solutions here. There's 2 times that this works. My base and my argument cannot be negative. The power can be, it just makes it be a fraction. But our base and our argument cannot be negative. Let's look at the right one. What can we do over here? Yeah, they have the same base here. Log base 5 of x minus 2 and log base 5 of 3x plus 7. If these two pieces equal each other, that means that my arguments are the same. So we want to know, when does x minus 2 equal 3x plus 7? Since my bases are the same, my arguments have to be the same. So what do we do here? Minus x, so I have minus 2 equals 2x plus 7. Minus 7, negative 9 equals 2x. Divide by 2, and I get that x equals minus 9/2. Does that work in our logs? It gives us a negative argument. If I was to put negative 9/2 in this one, negative 9/2 minus 2, that's going to be negative. So this is not valid. This gives a negative argument. Do we have another option to choose from? No. So where is our solution going to be? As I say, we have no solution. There is no time when these two logarithms cross. It's a negative argument. They don't go together. Okay. We're going to do a couple more. Just to practice these a little bit. Say it again. This is the very end of 5.4. Mm-hmm. What's up? It'll be tomorrow. Like, we flex things because we didn't quite get through everything we needed to. So it doesn't have to be turned in today. So, what can we do on this one? They have the same bases here. So all we care about is, when are these arguments the same? When does x plus 10 equal 8 minus x? So what are we going to do? Add x. So I've got 2x plus 10 equals 8. Subtract the 10. So I get 2x equals negative 2. So what does x equal? Negative 1. Is that okay, or does that make something invalid? That's okay. We have positive arguments on both of them there. And our very last one uses a piece we used a few times yesterday that we haven't used today, but we need to remember. What do we have here? How can we simplify this left-hand side? This, I would say you can put it in logarithmic form. It's going to get nasty if you do. This is trying to get you to remember that switching it into E thing that we did yesterday with the equations, where we have the, I'm just trying to remember how I read it, our E to the P ln of B is going to equal our B to the P, this piece. We used that yesterday when we were putting things into into the base E. So we took this and we made it look like this. Well, this guy looks like this. The E and the ln can cancel out. We just have to remember that this x is actually an exponent. So this is the same thing as 3 to the power of x that equals our 27. So this is using that property that we used yesterday to put things with a base of E, even though it already come with a base of E. So how could I solve this?
3.
Yeah, because we know that 27 is actually 3 cubed. So this is 3 to the x equals 3 cubed. So since my bases are the same, I know that x has to be 3. And that's a thing we can totally do.
So the thing in front becomes the powers?
Yes, and we're going to go into detail on that on the very next slide. Okay? Because that is, they've put it as like a property for memorization where it's really pulling up an exponent, or like a log property that we use like a billion times. But questions on these, because that's technically the end of 5.4. Because what 5.5 focuses on is that multiplier in front becoming the power, our product property, and our quotient property. So we're going to write those things out. So our properties of logarithms. And we're going to write all these pieces out, and honestly, we're probably mostly going to work with them tomorrow. We might get a little simplifying done. But our quotient property, our product property, and our power property. What these are, and you've seen them before, is if I have a log with any base, it does not matter what base it is, and I have two pieces that are being divided, our quotient, x over y. I could rewrite that. This is equivalent to log base b of x minus log base b of y. I know. So division becomes subtraction. Our product property, our log base b of some product, x times y. If division becomes subtraction, what do we think multiplication might become? Addition. Log base b of x plus log base b of y. And our last property is our power property. That's when we have log base b of x to the power of w. Because reasons, I don't know why property switches letters, but it does. Our powers actually come down and become coefficients. Powers become multipliers. So this is the same thing as w times log base b of x. And I wrote them in this order on purpose because I know it feels weird to have it start with quotients. But when we are expanding things and taking logarithms and making them bigger, we are going to go from top to bottom as we expand. Because that's what we're going to focus on a lot tomorrow. And when we are condensing, as in making them smaller, making them have fewer and fewer pieces, we are going to go from the bottom to the top as we condense. Whoa, my pen's being weird. I swear I'm not actually writing on the edge, but it's showing up on the edge. I love that so much. Let's fix that E, because that E looks absolutely insane. There we go. So we expand going down, we condense going up. That's not necessarily a law, it just makes it easy. It's kind of like doing PEMDAS as our simplifying and then solving, going backwards a bit. So we're going to work with these a lot tomorrow, focusing on these properties of logarithms. So 5.5 we will work on tomorrow and on Friday. So what that means is homework 5.5, which I'll get the numbers for up here in just a second. So this will be due tomorrow. 5.5 will be due the Monday we get back. And the quiz, we are actually going to do... take home. So I will, Justin, I will get it to you tomorrow. And Marvin as well. I'm going to get it to you tomorrow. So, that way we can take all the time we need in class to get through all the things we need to and not be trying to rush through it so that we have it in time. But I don't want to give us a quiz on the Monday we get back from a break. You? That would be brutal. And then especially since we have a test that week. If you are interested in a review for the quiz, even though it's take-home, I do have one right here. It will be a take-home quiz, so... Huh? The quiz back? The day we come back, Monday. So I have a review for the quiz. I'm going to give you the quiz on Friday. And you'll give it back to me on the Monday when we come back.
Is there a review for points?
I mean, I put points in. I don't put zeros in against you guys with the reviews. But I give you points for them because you're doing a lot of work.
Logarithms actually